This is M. Haritha, second year CSCB section in Adi Shankara Institution of Technology. Register number is 578. COA. COA means Computer Organizing of Architecture. Today topic is Tech Talk. COA Tech Talk. Topic is pipeline of vector processing and multiplication. Pipeline and vector process, parallel processing pipeline, arithmetic pipeline, instruction pipeline, RISC, pipeline vector processing, array processing, multiplication processor, characteristics of multiplication, interconnection, structure, interprocessing, attribution, interprocessor, communication, and synthesization. Parallel process. Parallel process is a term used to denote a large classes of technicals that are used to provide simultaneous data process task for the purpose of increasing the computation speed of a computer system. Second point, the purpose of parallel process is to speed up the computer processing capability and increase it through output, that is the amount of process that can be accomplished during a given interval of time. The amount of hardware increase will parallel process, and with it the cost of the system increases. Parallel process can be viewed from various level of complexity. At the lowest level, we distinguish between parallel and serial operations by the type of registers used. Example, shift register and registers with parallel load. At a higher level, it can be achieved by having a multiplicity of functional units that perform identical or different operations. Similarities. Figure below shows one possible way of separating the extensions unit into 8 functional units operating in parallel. A multiplication function organizing is usually associated with a complex control unit to coordinate all the activities among the various components. Added, subtract, processor register, then subprocess, adder, subtractor, integer multiply, logic unit, shift unit, incrementer, flow point, add subtractor, flow point multiply, flow point divided. The operand is in the register are applied to one of the unit depending on the operations specified by the instructions associated with the operand. The process performed in each functional unit is indicated to each both block of the diagram. The adder and integer multiplication perform the arithmetic operations in parallel. The logical shift and increasing operation can be performed concentratedly on different data. All the units are independent of each other, so one number can be shifted while another number is beginning incremented. A multifunctional organizing is usually associated with a complex control unit to coordinate all the qualities activities among the various components. There are a variety of ways that parallel process can be classified. It can be considered from the internal organization of the processor, interconnection structure between processor, the flow of information through the system. One classification introduced by M. Philemon considered the organizing of a computer system by the number of instructions and data items that are manipulate similarities. The normal operation of the computer is to fetch instruction from memory and execute them in the processor. The sequence of instructions read from memory constructions and instruction stream. The operations performed on the data. In the processor construction, the data stream parallel processing may occur in the instruction stream, in the data stream, or in both. Flyn's classification divided computers in four major groups of follows: single instruction stream, single data stream, SISD, single instruction stream, multiple data stream, SIMD, multiple instruction stream, single data stream, MISD, multiple instruction stream, multiple data stream, MIMD, single instruction stream, single data stream, SISD, represents the organization of a single computer containing a control unit, a processing unit, and a memory unit. Instructions are executed sequentially, and the system may or may not have internal parallel processing capability. Parallel processing may be achieved by means of multiple functions units or by the pipeline process. Single instruction stream, multiple data stream, SIMD, represent an organizing that included many processing units under the supervision of the common control unit. Uh, all processors reduce the same instruction from the context on the different items of data. The shared memory unit must contain multiple modules so that it can communicate with all the process similarities. Multiple introduction stream, single data stream, MISD. MISD structure of only of mathematical instruct single no particle system has been construction used organizing multiple instruction stream, multiple data stream. MISD organizing refers to a computer system capable of processing several programs at the same time. Example, multiple passes or multiple computer system. Pipeline. Pipeline is a technical of decomposition, a sequentially process into sub-operation with each sub-process begin executed in a special dedicated segment that operation consonant with all the other segments. The name pipeline implies allows of information analysis to an industrial assembly line. It is characteristic of pipeline that several computations can be in process in distinct segment or at the same time. Perhaps the simplest way of view the pipeline structure is to manage that each segment consists of an input register followed by the complementary circuit. The register handles the data. The complication circuits perform the sub-operations in the particular segments. A clock is applied to all requirements after enough time has except to perform all segment activities. Segments operations. Example, the pipeline organizing will be demonstrated by means of a simple example. To perform the combined multiple and add operation with a stream of number a multiply b plus c for I is equal to 1, 2, 3, etc. Each sub-operation is to be implemented in a segment within a pipeline. R1 A1, R2 B, input A and B. R3 gives rise to R1 multiply R2, R4 give to C. Multiply and input C. R5 gives rise to R3 plus R4. Add C to product. The 5 registers are loaded with new data every clock pulse. The effect of each clock is shown in table. The first clock pulse transfer A1 and B31 into R1 and R2. The second clock pulse transfer the product of R1 and R2 into R3 to C1 into R4. The same clock purpose transfers A2 and B2 to R1 and R2. The third clock purpose operation on all three segments. Similarities, it places A3 and B3 in R1 R2 transfers the product of R1 R2 into R3 transfers C2 into R4 and place the sum of R3 and R4 to R5. It takes 3 clocks purpose to fill up the pipe to review the first output from R5 from the on each clock produce a new output and moves the data one step down to pipeline. This has happened as long as new input data flow into the system. When no more inputs data are available, the clock must continue until the last output emerges out of the pipeline.